Kia ora Year 9. This video is a request from Kieran for me to do the 2 extended abstract questions in the practice JAF. So hopefully if you're watching this you've looked at the solutions we've put up in PDF form, but sometimes it's good to just see some different ways of doing the reasoning. So for the first question I'm going to show you how to get to the answer in a couple of different ways. The most important thing is that you're setting up a logical chain of working for these problems because there are quite a lot of steps. And as you know, if you need to put any extra angles in, just make up a letter for them and label them is the easiest way to go. So let's look at question 12. So for this one, I didn't write the words in, but what you have to do is to find angle J, and you have to give your angle reasons. So there are a couple of ways to go here. But the first thing that I want you to notice is that we've got parallel lines here. So you've got to look quite hard at the diagram. It won't be drawn to scale. You can't get out your protractor and measure it. You have to use your brain to figure it out using our reasoning. So looking at this, let's see if just from looking at those there's anything we can put on there. Well, we've got 37, but we haven't got a triangle yet. All we've got is parallel lines. But so far it's hard to see our corresponding alternate or co-interior pattern. But what I can do is I grab my ruler and I'm going to extend out this line and see what I get. Okay, let's see how it looks. So let's push that line out there. Now I could do that again, but let's just see where that gets me to. And I'm also going to extend out this line so I can see some more of the geometric stuff that's going on. Right, now this suddenly starts to look not too bad at all. Let's mark in this angle here. So lots of ways you can do this. You can go to this one, this is angle A. And now you can find that by saying this angle and this angle are co-interior. So you could go off and do that, but there's actually an even faster way to figure out angle J. Let's just take off some of this stuff. Take off that and take off the green bits. Oh, now I've lost my line. Okay, so let's just draw that line out by hand. There we go. Better, because I'm trying to get to J, is if I see this angle here is 37. Then this one here is also 37 because it's alternate. So let's look at how we can write that on. Well, we want to label this angle. So you can do it using the markings like this, W, X, Y, but most Year 9s tend to find it easier to use markings like this. So let's mark on angle B. What can I say now about B? Well, I can write down B must equal 37 degrees. That's because alternate angles around parallel lines are equal. So that's how we give an angle reason. We write down the angle and then we write down the reason. Now if you don't want to write the shorthand, that's fine. I've taught you the shorthand to make it easier. But if the shorthand's making it harder, just write out the whole sentence. Okay? Now what can we see next? Well, we can go straight to angle J now, because we've got this angle here is 62 and this angle here is 37. And now we've got a triangle because we extended that line out. So that means that angle J must equal 62 degrees plus 37 degrees because the exterior angle in a triangle is equal to the sum of the interior opposite angles. And again, you can just write that whole sentence out if you want to. So that gives me my answer. J is equal to 99 degrees. Right, so that's great, but I'm going to show you a slower way to get there, because I think lots of the time in geometry we don't always see the fastest way to get to the answer, and that's totally fine. What matters is that you set your working out logically. So well done if you saw how to get there in just 2 quick hops. I'm going to do it in about 4 to be a more realistic example. Before somebody emails me, we don't mind if you take 10 steps to get there, as long as you're justifying every single reason along the way. So let's take out angle B and go a slower pathway. So suppose we don't see B, but we see this one here. And we go, well, let's call that angle A. Well, we know that A and this angle have to add up to 180 because they are co-interior angles around parallel lines and they are supplementary, or we can just say equal 180 degrees. Or we'll say, actually better to say add to 180 degrees. So that's A. Now, that leads us straight on, hopefully, to seeing B. And B plus, so what did I get for A? I didn't put a value in for A. A is equal to 143 degrees. And now we can use angles on a line. 143 degrees plus B must equal 180. Angles on line equal 180. Now, suppose I've forgotten the exterior angle rule, which is quite a normal thing to do when you're a year 9. What can I do next? Well, I can find angle C, and that's just using angles in a triangle. Let's get some more space, we're running out of room. Okay, so every time I find an angle, I write down why I find that angle. So C plus 62 plus, what have I got there? I've got 37, must equal 180, and that's angles in triangle equal 180 degrees. So C is equal to 81 degrees. Finally, I can use angles on a line again and get J plus 81 degrees is equal to 180, because angles on line equal 180. So J is equal to 99. Okay, so why did I bother going through all of that if you're watching this video? Well, it's to show you that you don't need to go there in 2 steps. Maths isn't always about getting to the answer quickly. It's about showing all of your thinking. And so that's what we want you doing. So as I said before, we don't care if you take 5 different angles to figure out angle J. So that's the first way that I'm going to show you this problem. But there's another way that I think is really cool. So extending out your lines is always a good thing to do in hard questions, because it lets you see patterns with parallel lines. But let's go all the way back to the question now and forget that we've done that. So suppose we didn't remember that that was a good thing to try out. Here's another good thing to try out. I've got 2 parallel lines, and I don't know anything about angle J, but I'm going to get my ruler again, and I'm going to say, well, I've got 2 parallel lines. Let's just put in another parallel line here. So we know that there must be a line that's in between those 2 that's parallel. So you can visualize what I've done here. So I put that parallel line in, and now we're going to split that angle J up into 2 angles. And we're going to call the top bit angle B, and we're going to call the bottom bit angle A. So we can say I have split J into A plus B. And we need to say that A plus B will equal J. We could put degrees in as well. Now look what we've got. It is super easy. It's like a unistructural problem again. Because, except we didn't want to do that. Here's A and here's B. Now we can say that A has to equal 37 degrees, because you can see this one and this one are alternate angles. So alternate angles, parallel lines, are equal. And look what we've got up here. We've got B, here's B, here. These are alternate angles. Let's take off that big mess. Right. So B must equal 62, because alternate angles, parallel lines, are equal. But we know that J is just A plus B, so J must equal 99 degrees. So there you go. And that's full reasoning for that problem, right? You probably want to explain what this is. I have put a 3rd parallel line in. There we go. Okay, so nearly finished. One more question to do. Just 1 second. Alright, so hopefully you saw that there were several ways to do that question. This is question 13. This is the one where we've got lots of information that we have to pick out on the graph. The first thing to notice is I've got parallel lines. The second thing to notice is that I've also got an isosceles triangle. So you've got to figure out that those 2 things are going to help me solve this problem. Because at the moment, I have to find this angle over here, angle K, and I've only got 1 angle given to me. So let's just start, 2 angles, 67 and 74. So what's the only thing that we can see to do here so far? Well, we can do, I'm going to do this again a slow way. I'm looking here and I'm saying let's make that angle x. Now we know that angles on a line add to 180. So x plus 67 plus 74 must equal 180 degrees. So x plus 141 is 180. X is equal to 39 degrees. Now I have to give my reason. Angles on line equal 180 degrees. There we go. What can I say now? Well, now we've got the angle at the base of an isosceles. So we know that this must also be 39 degrees. So we can write down y is equal to 39 degrees because base angles, isos, triangle are equal. What can I do next? Well, now we need to pull in the parallel line reasons. So again, if I take my ruler and I do this thing, this just makes it easier to see. You can actually do this one without the ruler thing, but let's extend that out. There we go. What have we got down here? Well, this angle here of 74 has got to be the same as this angle in here because they are alternate angles. So let's give that top one a name. I'm going to call it angle Z. It's a Z. Shaky writing. So Z is equal to 74 degrees because alternate angles around parallel lines are equal. Remember, we have to write the parallel lines bit because alternate angles aren't equal unless the lines are parallel. So Z is 74. Okay, what can I do now? Well, now we're on to the easiest rule we've learnt, which is that angles in a triangle add up to 180. So here we've got 39 degrees, here we've got 39 degrees, and here we've got 74 degrees. So we've just got this little bit here, which is K. So 39 plus 39 plus 74 plus K is equal to 180 because angles in a triangle equal 180 degrees. 152 plus K is equal to 180. K is equal to 28 degrees. There we go. We've found angle K, and we've used parallel line rules, and we've used triangle rules, and we've written down lots and lots of reasons. So that's all for now on the extended abstract geometric reasoning. I'm going to do a video on angle reasons for Ka4 later on tonight, and I'll take any other requests if they come in about the next hour or so. Thank you for watching.